Hi guys, welcome back. In this video, we will discuss about change of order of integration. That means we will we will try to change the order of integration. That means here the limits are x equal to, as we discussed in the previous problem. By looking at the limits itself, we are going to get the idea of these limits belongs to which function, right? From that analogy I'm directly writing, the limits are from x equal to 0 to x equal to under root of a square minus y square, and these limits are y is equal to minus a to y is equal to a. Okay, right? Here we are integrating first with respect to dx, then we are trying to integrate with respect to dy. Now we will try to change the limits of this whole integral, then we will try to integrate in a different manner. Whenever you get a problem related to change of order of integration, first we have to draw the uh, curve of the limit, curve representing the limits of whole integration. Just consider x equal to under root of a square minus y square. This implies x square plus y square is equal to a. This is what this limit intends. That means this is the inner meaning of this. This is the inner meaning of this limit. That means we are going to integrate this f of x comma y function from x equal to 0 to up to a circle of radius a. That means if you consider a Cartesian coordinate system from 0 to, we are going to integrate in between these. This is then circle of radius a. If you consider, if you consider the limits of y, we don't know uh, what we call, we don't know which side we are integrating. Like from x equal to 0 to here, we are not considering the left side of the function. That means x equal to minus under root of a square minus y square. We are not considering this thing. We are not considering. We are considering only this area, because in the limits it said that x equal to under root of a square minus y square. Positive value of x square minus a square minus y square. That means we are going to consider only this value. Like that, if y limits are like from 0 to y, then we are going to consider only this quadrant region. That in limits it was mentioned that from minus a to plus a. So we are going to integrate this function from minus a to plus a. Then we will consider this whole region. This is the area of integration that we will carry out. I hope you guys got an idea of area means limit of integration and all those things. By looking at the limit, which uh, we judge that we are going to integrate our function f of x comma y in this region only. Now we will try to change its limits. Yeah. Now it's y is equal to a, y is equal to minus a, x equal to 0 to it's x equal to under root of a square minus y square. Okay, right? Now I will try to integrate from here to here and from here to here. The value of, as it is in circle, the value of x here will be a, right? As it is an point on the circle, we can take uh, y value on this on this curve as y is equal to under root of a square minus x square, right? As if you are going to keep x value as 0, we are going to get plus or minus a. As we are interested in negative region, we are going to take minus a. If you are interested in positive region, we are going to take plus a. This is the governing equation of the y. Now I will get the limits of y from minus under root of a square minus x square to under root of a square minus x square to what we call 0 to a values of limits of x. The same function of integration will be same, f of x comma y dx dy. This is how we are going to carry out the order of change of order of integration. This is the one of the example. Now we will discuss a problem regarding this topic. Now we will discuss a problem regarding evaluation of this integral by using change of order. Here already they mentioned the order. We have to integrate first with respect to dy, then with respect to dx. First, uh, we are going to draw the curves of these limits. Then we are going to change its order of integration. Just look at this. These are the limits of y as it is a function of x. These are going to be a limit of y. These are the limits of x. Now I will draw an uh, graph regarding those limits. First, I will draw graph for y limits. Y is equal to e power x. It's a continuously growing function, and y is equal to e. It's a horizontal line because y is equal to some constant is a horizontal line. Now I will draw limits of x. Just look at it. X equal to 0. X equal to 0 is a vertical line, that is y axis, and x equal to 1. At x equal to 1, if you are going to keep here as x value as 1, we are going to get y value as e. So if it is the y is equal to e graph, and when it's x equal to 1, these both curves are going to meet. So x equal to 1 line is x equal to 1, x equal to 0, right? Now I'm going to change the order of integration. Right. First, now what I will consider is mm, it's y is equal to e power x graph, y is equal to e graph, right? Now, now we are going to integrate in this manner, just like these vertical strips, and we are going to be bounded between these lines, both of these lines. Just consider it is x equal to 0 line, and it is a curve. It is a curve which limits the value of x, right? We have to find the value of x on this curve. Then we are going to get the limits of y. It's y is equal to e power x graph. If you want to know the values of x on this curve, we are going to get x equal to log y base c, right? If you are going to take this function, we are going to get it. Now we are integrating from y is equal to 0, 0 to y is equal to e. These are the limits of y, right? From here to here we are integrating. And the limits of x are like from 0 to this curve. Now I am going to change the limits of this curve. Log y base e to, no. From 0 to log y base e. We are starting from here and going to here, right? From 0 to log y base e. And limits of y will become from y is equal to 0 to e. The same function will be there, dx, dy, dx by log y. Now we have to differentiate first with respect to x, right? Here we don't have any function of x, so we are going to simply write x dy by log y base c, limits ranging from 0 to log y base c into dy. Limits of y are integral 0 to e. Now I will substitute this limit, integral 0 to e log y base c minus 0 by log y base c into dy. Yeah, no dy is there. And this whole term is going to get cancelled. Now I left out with integral 0 to e dy. Y ranging between limits 0 to e. So e minus 0. The whole term will become e. See, we are evaluating this complex function easily by changing the order of integration. That is the power of order of changing the order of integration. Whenever you get a question regarding changing the order of integration, first try to draw its graph. Then the question is going to be very easy. That's my one of the suggestion to you. This is up to this is all for this video, guys. Thank you. Meet you in the next video. Bye.